Welcome to the new episode of Green Guardians. I am Aishu Bharadwaj, Assistant Editor at Trade Promotion Council of India. And today we are welcoming yet another prominent personality. Please welcome Mr. Baldev Raj Narang. Thank you so much, sir, for taking out time and agreeing on providing us inputs. Welcome to our series.
Thank you. Thank you, Aishu.
And for our audience, I just want to tell you all who this person is right in front of me. Mr. Baldev Raj Narang is the Chief Executive Officer of Clariant Power Systems Limited. He is also the Chairman, Capacitor and Power Quality Division of India Electrical and Electronics Manufacturers Association, which is IEEMA. And Mr. Narang has over 45 years of experience in public and private sector. Sir, I just want to tell you that it is indeed our honor to have you on our series, and I am really excited to begin this chat. So moving on to my first question, I just want to know what inspired you, to establish Clariant Power System Limited.
Aishu, I'll just make some correction here. Basically,
Yeah,
sure. I am involved or associated with this Clariant Power System Limited as CEO.
Yes.
I have not set up or established this company, but I am part of the company. I am part of the growth journey of this company.
Yes.
This is one of the fastest growing company in the field of power quality and reactive power management. And we offer solutions in this field. We are also manufacturers of systems, and we design the solutions. And we cater to all the sectors, industrial sectors. We cater to utilities, renewable sector, OEMs, and wherever you can say all the bulk consumers of electricity,
right,
as well as now the bulk producers like utilities as well as the RE sector. We are there in all the fields. And what this CPSL means Clariant Power System Limited, it has given me a platform to use my experience which I have gained from various public sector and private undertakings. I started my career with BRPL, Bongaigaon Refinery and Petrochemicals Limited in Assam, after graduating from Delhi College of Engineering. And this BRPL was the first integrated refinery and petrochemicals project in India. And it was also the first project taken up by Engineers India Limited in this oil sector. After I was associated during all initial stages like installation, testing, commissioning, operations, maintenance, and all those phases I have gone through in this company. And then I switched over to a private undertaking called Century Anka Limited. It is a BK Birla Group company. And they were into polyester, nylon, tire yarn, and all those things. And they had foreign collaboration as well. And this Century Anka, this Clariant Power System Limited, they gave me a platform to use my experience. So that's all about this company you said setting up. It was already an established company, but it is the fastest growing company in this field. And I'm glad to be a part of this growth journey with the company.
Right, sir. So moving on to my next question, sir, given, I would certainly take advantage of your experience now. So with the increasing penetration of renewable energy sources into the grid, what are the primary challenges or issues the energy industry faces in transitioning from conventional sources to renewables? Also, what remedies or strategies, can address these challenges?
Right. This is a very relevant question. We are having a large-scale penetration of renewable energy sources into the grid.
Right.
And any new change or anything which is, you can say, coming up very fast and suddenly, there are challenges. And this sector also has a lot of challenges. And it's a big question, and the answer is not very small, but I'll try to summarize in very few words only. We are having this integration of renewable energy sources into the grid. And the challenges are there. I'm talking about the challenges with respect to the stability of the grid, the power quality status, and the voltage stability of the grid. What happened is in the year 2022, we have large scale isolation of renewable energy sources from the grid. To be precise, there were about 28 incidents when the renewable energy sources were isolated, and more than 1,000 megawatt of power was lost in that scenario. And what happened is these isolations, the CA took note of that, and they mandated certain changes. They said that we have to have a reactive power support, which is active support, dynamic support. Earlier, in fact, we had nothing. Initial projects, when they came, there was no support there, not even passive or active, nothing. But CA thought maybe the active support, the dynamic support may solve the problem.
Right.
But it's not that simple. The STATCOM is definitely a better solution compared to the switched capacitor banks, which we used to have earlier, or we still have those things. For many applications, we still will continue to need the switched capacitor banks, like for power quality motivation, what we call mitigation of the harmonics and other things. We still have some, you can say, dependence on the passive source also.
Okay.
But the problems are much deeper than only the reactive power support or the dynamic support, which we have been thinking. These situations are, these things have occurred. Thus, isolation has occurred after some faults. Whenever there is a fault, the problem is these sources, the renewable energy sources, are located at far end, remote ends, where far away from the conventional energy sources. The grid is very weak at those locations. The short circuit ratio, as we call SCR, is very poor. The inertia is very poor. And whenever there is a fault, it is not cleared in time. There is no source to feed the fault and clear it in time. The systems go out of synchronization. And whether we have a passive source or whether we have a dynamic source, it's not going to solve the problem unless we address the issue comprehensively, unless we solve the whole thing as a complete, you can say, installation. So this definitely will improve the situation, but it's not going to be that simple. So what is required is, when we are adding these sources, we have to have some measures taken for improving the grid stability.
Right.
If we have to add some synchronous generators, because they provide the stability to the grid, they have the inertia available, and they are able to remain in the system, and they are able to support the system for a longer period because of their inertia.
Okay.
Then when we have these renewable sources, energy sources, what is happening is we're having the grid inverters. These grid inverters are grid following inverters. They don't support the grid as far as inertia is concerned. If we have to have this mass additions, we have to provide battery backed inverters. Means they should be grid forming inverters, not grid following inverters. So the inertia will be improved. So we have to improve the inertia. We have to see that we don't just keep on adding the systems without strengthening the grid. So that is how all these things have to be taken care. And moreover, these trippings, whatever is happening, faults are occurring, the inverters, they go immediately out of synchronization. The power, this thing, there is a PPC available, that freezes. There is no control. The inverters and everything goes on the self-control. So what is happening is, this inverter selection also has to be improved. We have assortment of inverters, but there has to be emphasis on selecting the proper inverters. The inverters tuning has to be there. The grid modeling, the system modeling has to be improved. So all these things have to be done. Then only the systems can sustain and they can remain available. They can be, you can say, we can depend on them, and addition will be sustainable. Otherwise, if we keep on adding, the things are not going to maybe go the way that we want them to.
Right. So I think you have, very beautifully, sir, not just, talked about the concerns, but as well as the solutions. And I think, our industry actually needs, need to address these challenges as well as the solutions. So with this, my next question would be, what is the current power quality status in the energy sector? And how do renewable energy sources impact power quality? Also, sir, what measures can mitigate any negative effects?
The power quality status in the power sector or energy sector, or the you can say this total scenario
Right.
is not very encouraging. It is poor.
Okay.
We have a very poor power quality today.
Okay.
The reasons are that there is a very high concentration of non-linear loads today. Earlier, we used to have mainly linear loads, and non-linear load percentage was smaller, could be say 30-70. But now it has reversed, 70-30, means we have more of non-linear loads, less of linear loads. These non-linear loads lead to issues of power quality. They generate harmonics, and these harmonics, if they are not taken care, they are not mitigated at the point of generation, which is the consumer end. The customers, the loads they are generating these harmonics, not the generating stations, not the transmission, distribution, or utilization. Nothing. Utilization basically definitely. So these are generated at the load end. So they have to be taken care at the load end. And for that, if it is not done, these harmonics, they go back to the system. They travel to the system, and these are current harmonics. They get converted into voltage harmonics. They come back everywhere to all the loads. So that is what is happening exactly today. What is happening is these harmonics, unless they become a problem, the consumers, the loads, they don't take any action, because so long as they are able to manage, they continue to run like that. So it can be controlled only by regulations, because unless there is a ROI, nobody invests in such measures. So what is happening is the regulations have to be there. Regulations are almost non-existing. We started with Tamil Nadu state. They started with some tariff structures, penal tariff structures, where the harmonics, if they are fed to the grid beyond certain IEEE 519 guidelines, there was a punishment. 15% penalty was there on the power bill. So immediately people took action, and the things became all right. And that was also, you can say, on hold for some time. It was restricted to only some particular consumers at 11 kV, not at 33 kV, or 30 kV, not at 11 kV, which is the major load center. So it was also diluted to some extent for a long time. But again, now it has become effective. But except for Tamil Nadu, people are only talking. Other states are just talking of these measures. They have not put it into practice. This is not there in their regulations. This is not there in their tariff structures. So the power quality problems continues to remain there, and it will be solved only through regulations, because otherwise the investments will not come. So that is the status as on today. The next question which you asked is about the impact of RE, renewable energy sources, on the power quality. So what is happening is these renewable energy sources, they are also generating some harmonics during that process. So what is happening? These harmonics are not standard general harmonics which normally industry is generating. They are lower order harmonics are generated by the loads, normally 5th, 7th, and all. And they are very easy to be compensated both passively as well as actively. So that is easier. But from RE sources, the harmonics generated are of very high order, maybe mainly 23rd onwards, where the solutions are not easy. They are not economical also. The active solutions don't exist for these higher level harmonics directly at 33 kV, where these sources are connected. And passive solutions, standard solutions, are not viable. They are only for lower order harmonics. So they need a very special solution. And as on today, I could not find out any installation RE source where they have taken these measures. The harmonics are there. We are working in Australia. We are working in South Africa also. There are, you can say, solutions in place. There are installations which are taking care of these issues. But in India, we have yet to find installation where these things are in place and they are being taken care. The mitigation is happening. So that will start, maybe the people are working on that. But on ground, we have yet to see some installations with a positive result. So that is yet to happen.
All right, sir. Thank you. And with this, I want to know what innovative solutions or technologies hold promise for enhancing grid voltage stability and, addressing power quality issues resulting from the integration of renewable energy sources, sir.
The solutions are very standard. we cannot say them innovative. Innovative, we can say for passive, active solutions, we can call them innovative because in India so far, we don't have those active solutions at 33 kV for voltage stability. CA has mandated recently only STATCOMs for that. So they are providing the dynamic solutions, the fast solution, immediate with maybe 5 millisecond response and all. So, but they have yet to find a place in the actual installations. But the passive solutions have been there, and there we have to have reactive power support. So reactive power support is required to maintain the voltage, and this reactive power support is earlier it was missing from the installations. It was almost free for all. Nobody was asked to put any reactive power backup support within their premises of RE. So what happened is the all earlier plants, they are without any reactive power support. So there is a shortfall of reactive power installation in the system. The grid has these utilities, they have their own installations, but they cannot cater to the mass scale addition of this renewable power without reactive power support coming from them also. So now it has become mandatory. Now CA has mandated that reactive power support has to be there. About 33% support is required, reactive power. Only thing is there is a confusion whether it should be dynamic, whether it should be active, or you can say passive, or it could be hybrid. So from case to case basis, there have been some deviations, but in general, they are insisting for a dynamic support. So this reactive power support is required. And on their own, people don't come out with these things unless it becomes essential. Like in MP, they have a tariff structure where the reactive energy, whatever is consumed, it is chargeable. So if they have to pay for it, they go for the solutions. Otherwise, it has to be mandatory, either by tariff structure or by way of some regulations. So that is how this has to be done. And the dynamic support, definitely it will be much faster, much better. But it has yet to find a place in the country because we don't manufacture 33 kV dynamic support systems in the country. And these all systems are connected at 33 kV. So we have to import them. Maybe over a period of time, we may start doing some indigenous manufacturing also.
Right. All right. So the next question will be, during the transition to renewable energy, what strategies or best practices can utilities adopt to ensure a smooth transition while maintaining high power quality standards?
Okay. As I said earlier, so when we started 2 years ago, we had no regulations, or regulations or the guidelines were there, norms were there, but they were not being implemented.
Right.
So people were not having any reactive power support. They were not having power quality measures also being done. So these things, they don't come from the, you can say, developers themselves. They won't do it unless there is a reason for that. There is a compulsion from the regulations. So these things can be done only through proper regulations. The implementation and the strictness of the regulations can only bring these things. So this strategy means it is to be sort of initiated by the maybe regulatory authorities, and then only we can have, we can say, better voltage, better power quality status, and there have to be, you can say, either penalties or some incentives by way of these structures, tariff structures only. Then only these things can be brought in. Otherwise, the things will remain as it is, or the way they were earlier, without any support. And we have seen mass scale isolations also because of that.
Right, sir. And this is going to be my last question, sir. In the context of grid voltage stability and power quality, how do regulatory frameworks and government policies influence the transition to sustainable energy sources? And the second part would be, how can they be optimized to support reliability and sustainability while minimizing disruptions to power supply?
As I earlier also talked about the regulatory framework and the government policies, these are very important because here the investments are only because of these policies. Otherwise, people will whatever minimum is necessary for their generation, and they will just leave it at that. So if we want to have the power quality maintained, now it is there, the CA has mandated, they are not allowing the people to connect without power quality measures. They have to show, they have to first show on the modeling, they have to afterwards show on the field also that they have taken care of the power quality measures, the harmonics are within limits. So that has to be done. Even similarly for the reactive power, they are being asked to put at least 33% reactive power support. So this is only after the guidelines are there, the policies are there, the regulatory framework is there, then only the things improve. Otherwise, on their own, the things are just free for all. Nobody does anything on that. So this is required. Like even the power quality, we discussed earlier also. Here I'll again add to that. Power quality is basically getting spoiled because of the non-linear loads. And there we have a lot of emphasis. The government policies, the regulatory framework, or maybe incentives. There are incentives available. There is a Bureau of Energy Efficiency. We are doing a lot on energy efficiency, and which is a self-driven concept. People in any way will invest on energy efficiency because they are getting benefits. Even if there is no regulatory framework, there is no incentive, there is no Bureau of Energy Efficiency, still people will do it because it pays them. There is an ROI on that. And energy efficiency, we are having so much of emphasis, and one of the reasons of power quality deterioration is the energy efficiency itself. Because when we are implementing the energy efficiency measures, we are spoiling the power quality in that process because we are adding most non-linear loads there. So what has to be done is we can't give up the energy efficiency, but it should not be at the cost of power quality. We have to see that the power quality is also maintained while taking care of the energy efficiency. Now today, when we talk to the consumers, they suppose they have to go for a power quality measure, they have to go for maybe say power factor improvement, they have to go for harmonic mitigation and all. They ask for the ROI on that. These measures, the power quality doesn't pay you back. It is having no ROI, almost negligible. It is not viable. So it can be done only through a regulatory framework. So regulatory framework is required to see that we invest on power quality, because if there is no power quality, we'll ultimately land into problems. Whatever measures we take, energy efficiency or the power integration of RE sources, we can keep on doing on that, but we'll not have a stable power, we'll have interruptions, we'll have problems, and we'll have failures. Even the safety aspects also come into picture. Suppose the power quality is not there, it has to be mandated. The government policies, the framework has to be there. Otherwise, the safety is also jeopardized. What is happening is we find the fires in commercial buildings particularly, and there are problems in that. What is happening is there are certain standard already. The electricity code is there. There are regulations about earthing and all the you can say parameters about the safe installations. But one major thing which I find missing, which I have written earlier also, and I'm still continuing on that, they are having very you can say insufficient you can say cabling network. These things are coming. The fires are taking place mainly maybe because of the neutral conductor burning out, and neutral conductor burning out is a one of the reason is the poor power quality, because there are harmonics, the zero harmonics in the industrial, these commercial installations which add together and flow through the neutral along with the unbalance. The unbalance is also there, and then there could be a resonance also. So this neutral can carry 2 times the phase current and it can burn out, and which must be happening also at many places, resulting into fires and all. And we have to make it mandatory that people should not be allowed to use a small half conductor. They should be using a double conductor, as we have seen in IT installations and all. So these are certain things, the regulatory framework which have to come in and say that these things are required. You cannot get away with we can say by avoiding the investments in a proper installation. So that's what regulatory framework has said. It is very important, and we have to improve upon that.
Sir. So that's all for today, sir. And I genuinely want to thank you for, suggesting and for putting the right concerns. And I hope that your voice reaches the right people and right measures should be adopted. And for audience, I'm sure that you have enjoyed, and you not just enjoyed, this was quite an informative discussion, and you must have learned a lot about what is actually happening in the sector and what is all required. So with this, sir, thank you so much for taking out time. It was, again, I'm saying it was our honor to have you on our series, and I look forward to further collaborate with you. Thank you so much, sir, for your time. And for audience, till the time we are bringing the next leader, keep supporting sustainability. Thank you so much.
Thank you, Ash.